Hello everyone, this is the first part of 3.3 hydrocarbons. In this video we'll be covering the first two boxes. Carbon forms hydrocarbon compounds including alkanes, alkenes and alkynes. The physical properties of hydrocarbons depend on the size of the molecules. Compare the melting and boiling points of hydrocarbons given relevant information. Now that's an extension of what we talked about in 3.2, which is polarity of molecules, molecule polarities. Yeah. And the second one, the hydrocarbons are used as fuels and as feedstock for the chemical industry. You need to be able to write equations for the complete combustions of hydrocarbons. Okay, let's look into the first one there. Okay, we are skipping this slide because that's more of the points that we'll be covering. We will be watching this crash course chemistry episode on the hydrocarbons to gain more like an overall view of what the hydrocarbons and organic chemistry itself is about. Organic chemistry is something about compounds, something about compounds that contain carbon, and compounds that contain carbon are called organic molecules. And hydrocarbon is the other way around. Hydrocarbons are starting of that. So that's been already established there. Carbon compounds are referred to as hydrocarbons. Hydrocarbons contain carbon atoms. Now if you look at this diagram more carefully, you can see that carbon is being the center or backbone of these molecules there. You can have mouse here, methane, ethane, propane, butane. So you can see 1 carbon, 2 carbons, 3 carbons, 4 carbons here. And number of carbons can increase to gasoline, which is usually octane, diesel a bit longer, motor all much longer, and plastic. Same sort of structure, but they've got different amount. We'll be also talking about things like alkanes and ethene. Now they can come also with oxygen, sulfur, nitrogen, or chlorine, and other elements as well. But the core information that you need to have is that they all have carbon backbone, because otherwise they won't be called as organic things. Now speaking of organic, now the word organic in the general world, I suppose, or consumer world, it's used a bit differently compared to organic chemistry. Now for organic chemistry to be in chemistry, the word organic means something that has carbon. That's it, nothing more or less. But if you see things like organic Coke, okay, that would probably mean something else. Or if you have organic water, pure organic Australian water, that doesn't make sense in the chemistry sense. I think they had to change the labeling, so I think they just call it natural water or pure water or spring water, something like that, instead of saying organic. Alright, now carbon as backbone. Carbon can form a number of different types of bondings. Now it can have 4 single bonds because it's the valency, and it can have 1 double bond and 2 singles, or 2 double bonds, or even 1 single and 1 triple bond. Which is very unique, which makes carbon as very unique and make up different types of molecules. Carbon can also bond to itself, so like diamond or charcoal, carbon nanotubes, or carbon buckyballs type of thing. You can make up those things. They're all type of hydrocarbons too. If it's carbon only, it wouldn't be hydrocarbon because you need to have hydrogen to make up those holes. The electrons that are not used for bonding. Now, why are carbons so unique? Each carbon has 4 valence electrons. That's really that. It's a midway of filling up to 8. So it wants to share. Each carbon atoms can bond to a variety of elements, not only itself. That makes it very special as well. Now let's talk about physical property. it should be a recap of what we talked about. For non-polar molecules, because there are a lot of electrons there, but there are no polar component, what's available for secondary interaction is dispersion force. Hope you're saying that with me, dispersion force. For non-polar molecules, dispersion force is the only thing that's available. So temporary imbalance in electrons within the molecule causes temporary dipoles, and this causes a force of attraction between molecules. Now, for polar molecules, dominant intermolecular forces are dipole-dipole or hydrogen bonding, so they're a bit different. Now, if you can finish the sentence, that's good. The larger the molecules, the more electrons there are. Hence, what would you say? Hence, the greater temporary dipole-dipole can form. What does that mean? For larger molecules, stronger the dispersion forces would be, and more energy is required to overcome that bond, or sorry, it shouldn't be say bond, interaction between molecules. You get that? Because if the molecules have strong intermolecular forces, it requires a lot more energy for them to fly apart from each other. Hence, next page, there you go. So methane down to decaying. So there are one carbon compound to 12 carbons in there. And what you can see in the boiling point and melting point, let's just focus on the boiling point there. You can just see that the negative value becomes positive as you go down that last column. If you graph that, the boiling point is drawn with the broken line. It just goes up as a different trend. So if number of molecular mass increases, the boiling point and the melting point generally increases. Okay. What you also need to be able to tell is that these hydrocarbons can undergo complete or incomplete combustion. Something, the classification of reaction that was introduced last year. For complete combustion, what you need? You need fuel plus oxygen. That combustion is what we call anything that is burning. So you're combining that with oxygen, what do you get? You should get carbon dioxide and water all the time. Now, for balancing that equation, you have to balance C first, H next, and O. So follow Mr. Choi, CHO. Okay. Write three chemical equations with methane, ethane, and propane. Now, methane has got one carbon, and the rest of the bonds are filled up with hydrogen because it's a hydrocarbon. Ethane has got two carbons, yeah, and carbon are bonded to each other. The rest need to be filled with hydrogens. Should be 2 times 2. So 2 times 2, and then add 2 after that. Should be 6. 6. Hydrogens there. Propane is a molecule which have got 1, 2, 3 carbons, and whichever is fine, and the 2 carbons has got triple bond. So triple bond here, carbon, single bond, bonded to another carbon. Rest of the bonds need to be filled with hydrogen, and should be 4 hydrogen around. So yeah, try drawing that and let that react with oxygen. You should be able to balance it by balancing carbon first, hydrogen next, and then oxygen. Products are always carbon dioxide and water. Now, if it's incomplete combustion, you get a bit of mixture. You might get a bit of carbon dioxide, not sure. Carbon monoxide, for sure, CO that is, and also carbon itself as soot, so unburnt carbon particles. So those 3, and also water. So those 3 could be made from carbon itself, and water would be coming out from oxygen and hydrogen combining. So you get a mixture of those four. And most of the time, well, it's not really good. Incomplete combustion is not good unless you're trying to make charcoal, because carbon is an important fuel source for some people. All right, that's the end of first video. We'll be looking at question 14. They're to do with how boiling point increases as the number mass number increases, as well as you doing some balancing equation for complete combustions. All right, I'll see you in the next video.